Welcome back to STEM Online Academy. My name is Jason Masterakos, founder and president of STEM Online, where we help, uh, undergrad transitioning grade 12 students to undergraduate university students tackle hard to very hard midterm and exam questions through a rigorous reasoning system that AI can't solve. All right, so today we're going to be looking at why AI gets most hard calculus problems wrong. You heard me right. Wrong. Okay. Now, I know for those of you out there, you're thinking, Jason, uh, yeah, true, but it's more convenient than a tutor. Yeah, it gets it wrong, but eventually, if you prompt it, it will get it right. And maybe sometimes you only have to prompt it the second time and it gets it right. Or even the first time. Maybe the first time it gets it right. But how do you know for sure? No, really, how do you know? Because you take its word for it? No, you need to verify it. You need to have a critical mind. That's the point of this video, and that's the point of STEM Online Academy. Okay. What I'm going to be discussing in this video is how it's getting certain problems wrong. The funny thing is, if you watch the news lately, it seems when it comes to unsolved problems, lately it's getting some things right. But even those problems that it's getting right, it's after multiple iterations. Right, the first couple of times, it's not getting it correct at all. First couple of times, so you need to know what the AI is telling you. Okay, you just need to know, right? And that comes through knowledge, and that comes through being an expert in your subject. Okay, so here are some thought-provoking questions I'm going to discuss in this video. Is why can a solution look correct and convincing, right, but be mathematically invalid? Okay, that's question number one. And now question two, what does AI uh, often, skip when applying a theorem? Okay, question number three, why is verification more important than execution? Question number four, how can students use AI without becoming dependent on AI? Right? That's a student question because I am a, tutor, right? So I care about the education of students and my students per se, right? And number five, what skills make a human stronger than just being a calculator or a chatbot? So I'm going to answer question number one. Let's get right to it. I'm going to play the video, right? Why can a solution look convincing but be mathematically invalid? Well, if we look at the following, all right, so I made a simulation of how AI can get calculus questions wrong. So you'll look at, for instance, an AI output that you see for a particular question. Looks polished, looks like a real theorem, looks convincing, and maybe even the steps are all right and are convincing. But, however, right, it gets to a wrong conclusion. Okay, so that's the AI output. The student's job is to make sure, right, you're checking the reasoning, checking the meaning and the reasoning, and then you're going to prove slash verify. Okay, prove slash verify is the most important thing on this slide of this video right now. Okay, so if we look at the following problem, okay, determine whether I'm going to show why this is the conclusion that it gets is wrong. Determine whether the infinite series converges from the sum from n equals 1 to infinity of -1 all to the power of n plus 1 times brackets n all divided by n plus 1. Okay. Determine whether the infinite series converges. Okay. Now, an AI response, right? This is how it would behave. Okay. Now, I'm not saying I'm an artificial intelligence expert that I know that I'm able to predict its response automatically. Okay, but after interacting and testing it for myself, running tests on it, I know where it's lacking and more likely what its response would be. Okay. Remember, these are statistical models or LLMs, right? They're going to try to predict the next word based off what language you use. They're language models. Okay. So it's running a statistical analysis on the words and averaging what is the most likely outcome. Since it's averaging, it's not going to automatically, it doesn't know what it's doing. And it also means that it doesn't have it with certainty. Okay. So the AI response would be the signs alternate. Okay, true. It is an alternating series. I have to give it credit for that. Therefore, we should use the alternating series test. Yes, that's correct too. Conclusion, it will come to converges. And I'm not saying that it's not converging. I'm not saying it's not converging, but we can't jump to the conclusion. The problem is it jumped. Okay, more likely it will jump. All right, so let's go through this. Right. So that answers question one, that a solution can look correct but can be mathematically invalid. Okay. All right. You understand what I'm saying? There's a difference between the two. Okay. Now, why does AI often skip when applying theorems? Right. I mean, what does? What does AI often skip when applying a theorem? Well, it's not, we don't know exactly what it skips per se, but we do know that it's making jumps in reasoning sometimes. Okay. Sometimes to an intermediate amount of times, right? Gaps in certain areas of the reasoning. Okay. So we don't have a specific answer for that. All right. As mathematicians will tell you that in general, not just me. Will tell you that we don't know exactly what part of the theorem it is skipping. Okay. Now let's get back to the problem, and I'll answer question three at the same time. Why is verification more important than execution? I'm going to prove why verification is more important than execution. Okay, so we're evaluating it. Okay. Alternating series test, the gate, right? So the simulation sets, right? You have signs that alternate, yes. And that's the first thing, okay, that you have to look out for. For alternating series tests, you need to make sure it satisfies two conditions. The limit as n approaches infinity has to equal 0, okay, for it to converge, right? And then part two, it needs to be monotonically increasing. That's condition two, where b sub n plus one, rather than saying b sub n is going to be my sequence, okay? B sub n plus one has to be smaller or equal to b sub n, okay? So we know what my b sub n would be in this question. All right, let's go back. It's going to be the n all over n plus one. That's my b sub n, because an alternating series, it's automatically in the form of the sum from n equals 0 to infinity of -1 to some power of n, -1 to some power of n, well, times b sub n. So b sub n is the remaining part of the sequence. Okay, that has to be the n over n plus 1. That's b sub n. Now, we need to verify if b sub n plus 1 is smaller or equal to b sub n. So if we do that in our heads, or you can write it down whilst I'm doing it, think about it. Okay, b sub n is equal to n all over n plus 1. So b sub n plus 1 would have to be, replace all n with n plus 1. So that becomes n plus 1 divided by n plus 2. Okay, n plus 1 over n plus 2. Last I checked, n plus 1 all over n plus 2. Okay, all right, n plus 1 all over n plus 2. Now, careful. Does that satisfy the condition that b sub n plus 1 is smaller or equal to b sub n? Go right back here. Okay, look very careful. B sub n small equal to b sub n. B sub n plus 1 has to be small equal to b sub n. Okay, so b sub n plus 1. Get the expression for b sub n plus 1. So n plus 1 all over n plus 2. Okay, compare that with your b sub n. No, n plus 1 all over n plus 2 is greater than n all over n plus 1. So already one thing has been violated, one condition. And if one condition is violated, we may have a problem, right? So b sub n decreases eventually. No, b sub n approaches 0. Yeah. So you can see that there's some contradiction in somewhat of the reasoning. Okay. Now we can make a graph at the same time. If a series convert, now this answers the question why verification is very important. I just made my point that my reasoning didn't match the simulation, okay, or the AI simulation. Now, if a series converges, its terms must approach 0. Really? Another thing, let's also test. We already know that something's wrong with this. Because what the simulation is saying, what it's actually saying is that this sum should be going to 0. And that's not true. Okay. As you can see here, there's an asymptotic approach approaching 1, actually. Okay. This sequence to be this series of the sequence should be approaching 1. That's what our alternating series is. I'm going to prove that. Okay. All right. So as I said, yes, exactly. Pattern matching, alternating signs, as the simulation says, theorem name, hypothesis audit. And then comparing that with the mathematical reasoning, identify structure, check conditions, this is true. Choose theorem and verify independently. Yes. In other words, AI is a tool, right? But reasoning is your religion. Okay. AI is the tool, but reasoning should be your religion. Okay. So as I said here, I want to talk about the 5-second AI audit. Okay. Before trusting any calculus solution, I know a lot of students use AI. You want to be able to make the claim. What exactly is being asserted? 2, conditions. Did the theorem earn permission? 3, the cheap test. Is there a necessary condition or sanity check I need to do? Maybe I have to make a counterexample, whatever it is. And then also we have 4, meaning does the conclusion match the object's behavior? Compare things. Comparing things a lot in mathematics is very important. You can't compare apple and oranges. If you want me to prove that, I can. Well, I would have to prove things that are axiomatic that we should know anyways. But you should understand that. There's no dispute of that. Okay. And then 5 is the independence. Can you defend it without an AI response? Can you defend your reasoning without having AI assist you? Okay. All right. Now, back to what we were saying, I want to also show that condition 2 is not valid in the alternating series test because in order for this to be satisfied, to use alternating series test, to use an alternating series test, the conditions, both conditions have to be satisfied. Already one hasn't. So first off, I don't know if we can claim that this is a regular alternating series, even though it has that -1 to the end. So even that assumption is incorrect if you think about it. Now that you think about it, yeah, because it needs to satisfy both conditions. That b sub n plus 1 has to be small or equal to b sub n, the sequence. Okay. And that also that the limit as n approaches infinity of b sub n has to equal to 0 in order for it to converge. Well, guess what? It actually, there's a paradox here. The fact is that it doesn't converge, right? It's actually diverging, because if you take the limit as n approaches infinity of b sub n, okay, you have a limit as n approaches infinity of n over n plus 1. As n gets really big, n will start to you know, get really big as well. So the n's will cancel, n over n divided by n over n plus 1 over n. Okay, 1 over n gets extremely big, so 1 over n is 0, n over n is 1. So you will notice that you get 1. Okay, so what turns out is that our series is actually approaching 1. Okay? I hope I made my point that if you verify things as opposed to just taking them as they are, it will give you a better understanding of how the mathematics is actually working, right? Because if not, then you have a serious issue. Okay, so make sure you are verifying everything, especially nowadays. You don't know where the information is coming from. So you need to make sure that you're understanding how to use the tools correctly, right? If you use the tools correctly, then it's not a crutch, right? As I've put on the board, AI is the tool, but the reasoning is your responsibility. Okay. Again, the reasoning is your responsibility. So if you liked this video and found it helpful, please like and subscribe. Like and subscribe new viewers. It always helps the channel. There'll be more interesting topics coming very, very soon. So like and subscribe for new viewers. And again, if just want to let you know is that school is starting very soon. Okay, under a month. It's like 3 weeks. If you are you know, starting university or any university student, and you are nervous about or don't have confidence in uh, your mathematical ability, then STEM Online is here to help you, right? Okay, we have amazing tutors, five-star reviews, and 6 years in the business of helping people change their educational trajectories. Okay, so if you want more information, there'll be a link in the description below where you can contact me. Okay, again, like and subscribe. And STEM Online Academy is here to make the next generation of engineers, mathematicians, and scientists. Thanks again, and I will see you later on in the week. Have a great day.